anything you didn't get? Questions? A little bit of review?
On number 13, I got like A, and then on B, like I understood the answer they got in the back of the book, but I'm not sure I'd be able to find, like I understood that answer, but I'm not sure I'd be able to find the answer like another column in the future like that.
Okay. So she's always indifferent between 2 and 1. Suppose that Carmen has basketball. That's what
It was the
optimal bundle.
in solution like you were talking about at the end of last chapter. Situation. Yeah, corner, sorry.
Right.
There wasn't a graph in the back.
So you just basically calculated what the optimal consumption bundle was, right?
Yeah, I'm not sure. Because like they don't, like since you don't have a utility function, like I wasn't sure how they calculated it.
So what did you get for A? What did the indifference curve, did you get that?
I had the indifference curves were like straight, like downward sloping lines with constant slope, and like when I looked in the back, it said that they were like parallel because they're perfect substitutes.
Yes.
So like I have my.
Do you really get that part?
Yeah.
Okay.
I got my indifference curves, so they still very different at the 2-to-1 ratio.
So it leads to a corner solution. Remember corner solutions? So in general, I think maybe this will help. If your indifference curves look like this, so U1, U2, U3, and now we bring in a budget line that looks like this, where does the person get as happy as possible? If this person's at this point, could they be happier?
Yes.
Where? They could be here, but the one I'm not showing is where else could they be? Where's the highest indifference curve? Right here, right? And then same thing is true if the price ratio is such that the prices look like this. Now, I could be, let me cut across all three. I could be here, but I'm happier here. Everybody's with me on that, right? I'm happier here, but the happiest is at the corner, where the sum indifference curve I'm not showing puts you on the highest level. So it drives you to a corner solution.
So then what if, in this case it wasn't, but what if the budget constraint had the same slope as the indifference curve to where they were like on each other?
Yeah, that'd be weird. So then you can be, then you could be anywhere. There's multiple solutions.
Okay.
Yes. If the price ratio and the slope of the perfect substitutes were all the same, you could be anywhere. You're truly indifferent between any combination. Okay. Any other problems on chapter 5?
Can you just re-explain how you know on the income effect and the substitution effect, like which one is bigger?
Which one's bigger?
Like which one's stronger? Oh yeah, I'm sorry.
Okay, so it does depend. So the answer is it depends on the shape of the indifference curves. So let me just,
Do the thought process of how you
yeah, let me just go, yeah, that's what I was thinking. Let me kind of run through the thought process here. So if we, what do you want me to do? What would you rather have? So if I got, let's just go ahead with some x-rays and clinical charts here or something, I don't know, whatever, cars. What do you want a decrease in price of? Or an increase in price? Tell me what you want to do. Let's structure the problem the way you want it. Increase or decrease in the price of the vertical or horizontal axis variable? Vertical. Increase or decrease? Increase. All right, so we've got something that looks like this, right? Where the budget line is, you said an increase in price. So the budget is rotating inward, right? So a person's indifference curves could be anything, right? They could be even these crazy ones, possibly. So we don't know what they look like. So that's part of your answer, is it depends on the shape of the indifference curves and where you do. So the mechanics are always the same, though. So you always need to fall back on the mechanics. So I'm just going to make up a couple here. So U1, and let's just say U2. And then we're dissecting this thing. All right, so we're going to take the step 1, take the new prices to the old utility. So budget constraint rotated in. I'm going to take that up and look for the tangent point there. So something like this. So now our total effect is moving from A to B, but we're going to dissect that total change. So there's your total effect that we don't want to lose sight of. The substitution effect is moving from A to, let's call it A prime. So there's your substitution effect. Now what might seem weird in your brains is that I just dissected the substitution effect on the horizontal axis good. You might have found that this didn't seem right or something was kind of strange. That's because you might have been in your mind thinking about its effect on x-rays. Because here is the substitution effect. Here. X-rays got more expensive. I bought less of them, right? I bought more cars. So that did that throw anybody, or once you get into thinking about it, just remember that the substitution effect and the income effect are on both axes. And so if something seems counterintuitive to you, it shouldn't, because the substitution effect is always the law of demand. Price goes up, people buy less. That's the substitution effect. And so that's what's going on here with x-rays. But here it seemed kind of weird because we're increasing consumption when the price went down. But just remember the mechanics here, that we're actually changing the price of x-rays, holding this constant.
Why is that distance along the x-axis from B to A? Why is that the total effect? I thought the total effect would be from B to A prime.
The total effect is always our starting place and our ending place. So that's the total effect.
So the substitution.
I haven't done the income effect. Yes.
The substitution effect doesn't have to fall within the total effect.
Well,
That's right. No, it doesn't. Depending on what's going on with, now it does up here. See, the total effect, we move from, and I just kind of coincidentally, let's just say that, again, it depends on where this point is. But if we're going to how I got this drawn, which might end up being a Giffen good or something because I didn't really pay much attention to what I was doing, the total effect is from A to B, the substitution effect's there, and then the income effect is the distance from A prime back to your other point. So that's this total effect. So the
don't confuse us by saying with this total effect. Like you said, A prime to B was this total effect, which is the income effect.
well, which is this right here on this particular problem. I'm going from A prime to B is the income effect.
Yes, but you just kind of.
Oh, I said that wrong? Okay.
No, you just had some confusing verbiage. That was just
Okay.
like, yeah, the
All right,
income effect is this total effect right here.
All right. This, yeah, so I shouldn't have mixed I got you. Yeah. Okay, so the income effect, though, again, coming back to your axes for good x, if this is x-rays, then it's this from this point A prime, wherever that tangency point was, to here. Now, again, this one probably would have made a little more sense if my indifference curve would have came in like this. Now you got kind of all the things matching up a little better. Substitution effect, and now this would be the income effect. And it would be a little bit of a positive income effect. So this was actually an inferior good, the way I'd drawn it the first time, because the income effect ended up reducing the amount. Okay? So work on that a little bit more, but that's the motions. You might... Yes.
I was a little confused on the point as to why Yoshi wouldn't just be consumed at
20.
They're saying it was expected that he had over 600 for income or whatever.
The answer was, well, it said at least.
Yeah.
Because the slope, I would need to look through it. Does that make sense, Michael, what John's saying? The slope changed?
Well, I have a question on
I guess. I mean,
So since Yoshi
I
cut back on
understood that.
soda, the government raises less than 100. Oh, which is an important thing. At the same time, the government spends 100 subsidizing Yoshi. The government is therefore worse off. Okay, so I mean that brings up. Let me, I guess, start by. This is in some ways similar to that consumer surplus
I mean, it
issues with a
takes-
tax.
well, yeah. Well,
Right,
I was
because-
even questioning the revenue for the government. Okay.
So if we start doing this, we've got the quantity
Yeah,
being
yeah.
reduced, right?
I wasn't worried about the tax or the government or anything like that. I was
Okay.
just
He's on
confused.
A.
Yeah, I'm on A.
Oh, you're on A.
Yeah.
I'm sorry.
The tax is part of the whole prompt. But I was just confused. I mean, like, well, if he's got, a certain amount of income, I feel like there's either one point or, he could have a set amount of income and actually be consuming more with the tax or anything like that.
I guess the way I
Because the
looked
way
at
I drew it, it wasn't to scale with the graph, and then it just looked.
the way I looked at it, and like mine was kind of off the first anyway, but the way I looked at it was just that his indifference, like when his income or when the price changes,
Mhm.
like his budget constraint is going to, like the slope of it is going to change, and so like to be on a higher indifference curve, it's going to shift to where he's purchasing more of the plaza good and less of soda because of that price of soda increase.
Yeah, because of the relative price change.
Yeah.
Yeah.
But I don't know. On B, I was confused because it said that he would be better off because he was at a higher indifference curve. But I thought maybe like it would depend on like where I don't know.
With
Like,
the budget.
like wouldn't it depend on what his indifference curve shape was, which they don't like you don't know for sure.
No, no, because indifference curves can't cross. So he'd have to be on a higher one at that new price ratio, given the circumstances here. Since indifference curves can't cross, he'd have to be at a higher one. So that picture in the back kind of tells it here. Since indifference curves can't cross, there has to be an indifference curve that leaves him better off.
What if like my thought was like what if I guess it would be less with the indifference curves than the budget constraint. Like what if your budget constraint didn't necessarily switch by quite as much?
I think that's where my question was actually,
Okay.
because what I crossed out was like, when I put the budget lines, the indifference curve, instead of moving out, moved in.
Yeah, like
So I was like, well,
budget.
he could
The indifference curve moved in?
Well, like no, like he was just at a lower indifference because of the way his budget switched
Yeah.
by the
Wasn't it rotating through the optimal point though?
well, what if that's
I don't
not your
know.
optimal point? I mean,
I feel like there's not enough.
looking at the back of the
Maybe that's what it is. Yeah, because what I'm seeing, and I haven't looked as closely at this, and maybe it's
you
worth.
just ignore the
Are you
back.
guys on board with this, or would it be worthwhile to
We
go
thought
through
we
it?
actually-
Yeah, I thought it makes
Well, let's go through it then. If you guys, you think what?
They
think
thought
it
it
makes
makes
sense.
sense.
Yeah.
Okay.
I mean, it does make sense, but at the same time, it could
It makes
make
yeah, like it makes sense, but at the same time, like if you read it, if you didn't,
all the questions were very vague.
but yeah,
At
it
a
makes
price
sense.
of $3, so at a price of $3
So
each,
that's why it goes up.
Yoshi, a typical New Yorker, drinks
No.
200
Is it- no, we just-
44-ounce sodas each year. Concerned about burgeoning obesity. I like these current events. This was right in the news here within the last year or so. The mayor of New York proposes this is exactly what they were proposing too. Proposes the 50-cent tax on such drinks. He then proposes compensating consumers for the price increase by mailing each resident a check for $100. So you've got the optimal quantity identified. So we got soda here and we got some composite good here, right? and they're both equally priced. So the slope is 1 of the budget constraint. Weren't they equally
No,
priced?
not.
$1, $3.
Oh, I'm sorry. Why did I? Oh, price at $3 each. Oh, I was thinking each. Good. So okay, got it. So 3. So what do we got for slope?
3 to 1.
3 to 1. Negative 3. Right?
Well, it's actually it's 1 to 3, so it's 1/3.
Price of soda is
3.
3.
No, you don't.
Sounds like we need to do a little thinking
Yeah,
here,
no,
don't we?
it's 3. It's -3.
That's the one thing you guys got to have right off the top of your head. So the slope of the budget constraint is the price ratio. What's that? It's the ratio of 2 prices. What always goes on top because we've memorized it every time? The horizontal axis variable. Whatever it is, whatever's down here is what belongs up top. Just kind of burn that in. Now you can justify and double check your work. Like, oh, I'm not sure it was a top or bottom. Go back to the little rust trick here of this is dollars per soda. This is dollars per composite good. Flip the denominator, multiply it times the numerator. Composite good, rise over run, number of units of composite good, number of units of soda. That's a nice little thing to fall back on. Start by memorizing it, then double check your work with this little thing. And the reason I'm kind of hammering you on that is today we're going to get into production, and we're going to have labor and capital, and we're going to talk about a production function where we're measuring the marginal product of labor and the marginal product of capital. And when we look at the isocost line, there's going to be the slope of the expenditure function of a cost function. And that cost is, guess what the slope's going to be equal to? The price of the horizontal axis variable, which is the wage, divided by the price of the vertical axis variable, which is going to be the rental rate of capital. So it's going to stay with us forever. So keep that in mind. Thing on top, thing on bottom. Okay, so we had 200, right?
Yeah.
Was some sort of optimal point?
With no idea of how much.
With no idea of composite good, right? All right, and then we had a change in the price of soda, increase, budget line rotates inward.
But they're getting,
Yeah,
but
you're
they're
getting.
getting $100, so like it like.
Right. So we'd have to, well, let's see.
So the budget line essentially.
You can calculate this though, right? Yeah, you said we don't know it, but,
More numbers in.
well, we got,
You know the composite good costs $1, and then so like I mean like you're saying like you don't know how many composite goods, but like the 600 divided by.
Well, you don't have an income. Is the thing.
but you can make one up.
No,
You know that
have
the change
more.
in income is going to be,
Supposedly you have more than 600 if you're consuming at 200 and you're not optimally consuming soda.
no, but you're first optimally consuming soda. I think we can assume that in the problem. Even if it, yeah, if it doesn't, if it says at a price of $3,
But then
The
you're
Not
graph-
every problem-
The graph even graphically shows you're not optimally consuming soda, though. Like the graph that they provide for you is saying
that's not what I see.
that's what I see.
U1 in the back of the book?
Yeah, U1, you're consuming soda and you're still consuming composite.
That's optimal, but you're not maxing out on. So
That's optimal
yeah.
under the given conditions. So if this is a budget constraint, we've got the price of soda times the quantity of soda plus the price of composite good times the quantity of the composite good. And we know this, we know this, we now know this is the optimal quantity. So we're only missing this and this, and we're ultimately looking at a change in income. So you could plug any number into here and make up some numbers. Just suppose income is $10,000 or any number you want. Or you could leave it as a function of I if you wanted to be fancy. So you,
yeah, they just left Y as whatever.
they just left it as a function of income? Yeah. So then you could solve this equation as a C as a function of income. whatever that turned out to be. So then you've got your optimal point. So I think this clears up where you guys are at. So now we've got some mechanics to actually place the line. Take the 100 or change the price to 50, rotates this in, but then give $100 back, rotates it up. Now that looks different than what the book does.
Well, we.
Oh, I did the wrong axis, yes. That would help, wouldn't it? So we go like this, and then we bump up the soda, and that's the picture in your book. So let's not spend any more time on that. I think that's right. If you guys go back and work through, if you have any questions, I'll see you in office hours or after class. Okay? But I think that's what went on. We dropped the price. If you actually plug and chug some numbers and really graph it out, it should turn out to be like that. Yep. Is that what you did, Cadence? Did it work? Did you actually?
We didn't even have to. We didn't have to plug in the numbers.
Okay. Oh, you solved it using the income.
Yeah.
Okay. Yeah, that's possible too. Using it as a function of I. Okay, anything else on this homework? All right, so I kind of foreshadowed where we were going with this next chapter, which I think if you understand chapter 5, you'll find this pretty easy. We're not quite to maximizing profits, but this is our first introduction into the theory of the firm. I can see the reason your author did it this way, why the authors did it this way, is because it is the same mechanics mathematically as what we just came out of. So we're going to look at a problem for the firm of minimizing expenditures subject to a certain production quantity. So that's going to be our producer problem. So we're getting into, first of all, producer theory more generally here as we go into the upcoming chapters. We're probably going to keep in mind the behavior of the consumer, but really focus in on the firm. We'll come back to the consumer a little bit more when we get into pricing and other things like that. But now it'll be wearing your company cap. And you're the company. How do I maximize profits? How do I go about doing things? So with producer theory, our overarching theme is to maximize what? Profit. So we're going to maximize profit. This is our most general case. Of course, economists study nonprofit organizations and people maximizing some other objective function. But for the most part, we have the vast majority of companies in the United States out to maximize profit. So how do they do that? So this chapter 6 starts us off with a subset of that. So this is a subset of that problem. Subset of profit max. Because it's going to be characterized as an expenditure, a cost minimization problem. A subset of profit max by setting up a cost minimization problem. A cost minimization problem subject to a fixed quantity produced. Oops, question mark. Fixed quantity produced. So you can think about it this way, from a business standpoint, in layman's terms, it says, I want to crank out 100 Mountain Dews today. What's the most efficient way to do that? What's the most cost-effective way to crank out 100 Dews today? Okay, so that, to kind of characterize that in simple terms, what is the cost min way to crank out quantity equal to 100 units today? That's the problem we're tackling. Notice what that avoids is pricing, for instance. We're not talking about oh, should we do a new marketing campaign? Should we raise price? Are consumers elastic or inelastic? We're shelving all of that. We're simply saying, I want to produce a quantity of 100. What's the least costly way to do that? So as we set up this problem, what are the pieces of the puzzle as I've characterized it here? You guys tell me. What do we need to know? How do we start to maybe think about an equation that describes some of the things I would need here? What are my choice variables on a problem like that? So I walk in today, hey man, we got to crank out 100 units. What choices as a manager or a business owner do I have? What are my choice variables? The resources, right? So my choice variables are the quantities of resources I can employ. So can I go in, if we're talking about today, can I go in and negotiate some new wages with my employees? No, we're probably taking as given the prices of those resources, right? Can I change everything about my business? Like, what are some things I wouldn't be able to change if this is a daily decision? The supplies, the building, the rent, a lot of fixed costs that we talked about in principles class, right? So we kind of got this fixed cost, variable cost thing. So we're not going to be able to change some things. Okay. All right, so our choice variables are variable resources. Variable resources. What does that mean? Resources that I could actually change today, right? Resource quantities that could be changed today. All right, so our most generic function we could think about in production would be to show quantities of due expressed as a function of labor and capital. In reality, there's 100 different types of capital that went into the production of the due. We had a machine, we had a computer, we got a building that we're operating in, yada, yada, yada. 100 things worth of K of capital. And we also have our choices of labor. And we've got a lot of different people on the production process potentially that influence our labor. Some of those might be a salaried individual that I can't change what they're doing today, but some of them might be an hourly person that I could say, hey, you need to punch out today or come in late. We don't need you till 4 o'clock today, right? So we're thinking about the things we can change, the things we can't change. So our production function is the first thing I want to think about. Our production function is the quantity of the final product expressed as some function of labor and capital. There's our most generic way we can do it. Similar to our utility function, our utility expressed as a function of Legos and kites. All right, our happiness is based on our consumption of Legos and kites. Now we've got our production of our good expressed as labor and capital. Okay, what does that cost function look like? I gave you a little hint over here. What does the cost function look like? And this is the total cost function, by the way. It's not a marginal cost function. It's a total cost function. Okay. Let's just write it out. My resources are L and K. So just kind of Talk to me in equation language. Put on equation goggles.
Fixed costs.
Okay, we could bring in some fixed costs, and we will, but we don't have to at this point. How do I reflect my total cost of production? All I have is 2 resources. I said that theoretically we'd have a lot more, but let's just say we only use this resource called K and this resource called L.
So you have
Brianne? The sum of L and K. So the cost equals L plus K. So if I've got 100 units of labor and 3 units of capital, my costs are 103 bucks. That's what that equation's telling me. So I have 100 units of labor, or 100 hours of labor, if you want to think of it that way. 100 hours of labor and 3 machines, 3 units of capital. 100 plus 3 is 103. I've got $103 worth of costs. How's that sounding to you?
what's the per unit that you have?
Per unit. So we're missing, right now that's just expressed in the quantities of capital and labor.
So you have,
But I want the costs, so what do I need to do?
you recognize it as a price per labor? Or
Yes,
per
a price per labor and a price per unit of capital.
So it's a PL
A PL and a PK inserted in here. Just like our expenditure on Legos and kites was, did I write one out here? Yes. Right? Price of sodas times the quantity of sodas. That gives us our total cost of production. I'm using the resource labor, the resource capital. What's the price of labor? What's the price of capital? So I don't know if it'd be helpful for you to think of it that way since we've been kind of rolling that way. Let me do 2 steps for you. I wasn't going to do this way until I'm responding to the way you guys, your thinking caps are going, which is fine. So if we take the price of labor times the quantity of labor used, and the price of capital times the quantity of capital used, we've got our total cost of production, right? Our total cost. So in micro class, we used a TC here. I'm going to follow in line with your textbook here of just using a C, which I think will be more helpful than hurtful. But so total cost, our cost function looks like that. But we are going to let, and this should be easier as well, cost be equal to W times L plus R times K. And this is now the wage, which hopefully will be intuitive for you. The wage of labor, hours of labor. This could be hours, this could be people. If we need 4 people and we got to pay each person $100 per day, as long as your units match up, it doesn't really matter. So this is units of labor, however they're expressed. Possibly some questions might be in hours, or it could be in people, it could be in some other unit, but somehow it's a variable unit. And then R is the rental rate. So we're going to rent that machine. If you, I did some tile work at my house, and I went to the rental store and got the tile cutter machine, right? And they charged me $35 for the day was the rental price on the capital. Your commercial space for your building has a rental rate. So we're going to be thinking about that way. Even if you own the machine, economists like to say, well, what could you have rented it for? There's an opportunity cost to owning it also, right? So got to be thinking about opportunity cost if there's not an explicit price given. So this is the rental rate of capital.
So if you were to own it, you're still considering the rental rate cost.
Yep. You should, for an efficient decision, because otherwise you might miss out on, I could be renting it out to somebody else for $100, and going down the block, I happen to find the rental store, they've got a 50% discount, and I can rent it for $50 myself. So it sounds kind of foolish, but there's an opportunity cost to think about. It'll make you place your resources in the right place by always considering the opportunity cost. And then just to complete things here, this is the units of capital. All right, so that's our cost function. And that's the 2 pieces of the puzzle for all of chapter 6. We've got a production function which I haven't shown the details yet of, but we're going to have explicit functional forms. And we've got a cost function that's going to look like this. Now, if I graph this cost function, what does it look like? It's a line. So very similar to the budget constraint, this is a kind of a constraint that we have, a cost constraint. It's going to end up being what's called the isocost curve. We could express this in slope-intercept form if I put labor on the horizontal axis and capital on the vertical axis. You could manipulate this equation to come up with a slope-intercept form, which would be a straight line. And we're going to call this the isocost line. The isocost line. Why the iso part? Because cost is constant along that line, right? I can have this many units of capital and this many units of labor, or I can be here. How much money am I spending? The exact same amount of money. So along an isocost line, all combos of labor and capital cost the same. Along an isocost line, all combinations of labor and capital cost the same. The total cost is the same. And now you start to see some real world stuff going on here, right? Do I use a machine and less labor, or more labor and less machines? You see the mix of capital versus labor, the resource mix starts to come in. And that's from a cost perspective. All right, questions on that? It is. Yep. So this one's kind of a mirror image of the budget line. So here is our problem to kind of motivate this.
You said at one point that that's also called the isocost curve. Do you get?
It is not an isocost curve under these conditions. If the wage rate and the capital rate are given to you in a competitive situation, you have no power on the price of resources, then it would be always a straight line. What's that? Yes.
What are we looking at?
Just the first one. I want to characterize the problem.
Which one is the first one?
Oh, sorry. The one with the production function on it. The, what is it? Pizza. Pizza producer. All right. Okay, read that problem and let's talk about it together on how we'd approach this thing. We're throwing in some old principle stuff right away. So you brought up short run. Why? Short run versus long run. What's the difference? Variable, yes, you can't change anything. So variable cost, it brings up variable cost and fixed cost, but at the purest form of the definition, it's your production function. Not the money, the production function. When I walk into work that day, some of my resources cannot be changed. They are fixed. The building cannot be changed. I can't swap my building out. So we're going to show that mathematically by putting a bar over the top of the K. See the bar on your problem? So capital is assumed to be fixed in the short run is a common way we start to approach long run, short run. That means that we're taking capital out of the picture. It's no longer a choice variable. It's not a variable resource. It's a fixed resource. Okay, but our production function's there.
Do you put the 3 in where K?
Okay, good. So yeah, what do you want to do? So write an equation for the short run production function showing output as a function of labor. So what did you want to do? Put a 3 in where the k is and solve it out. That's going to flush out that k. And so part A is expressing the function as L only. So at the end of the day, you're just going to have an L over here. The k vanishes into a constant term. All right, that's it for today. Finish out the rest of this on your own. It's in your book. You've got the answer. We'll talk about it on next class on Friday. But I'd really encourage you to, before you look at your book, try to see if you can think through. In fact, let's do let's talk through part B right now. Well, how would you do it? What's that, John? Plug those numbers back in for L. Okay, so 1, 2, 3, 4, you're just plugging and chugging. I mean, this is just plug the L equals 1, what do I get? L equals 2, what do I get? And so you're going to create a schedule of numbers. So we'll review that on Friday. Yes.